I worked for a long time at the German Central Bank, and we are not a neutral institution. You know, there is a house view that has to be adhered to, so the review process is much more limiting than what you described. But some of the problems were the same, and some of these problems are at the heart of what I'm going to talk about. And it boils down to two things, two trade-offs that we have accepted. The first trade-off that we have accepted is that our data is available to commercial enterprises. We create this data, they use it, but their algorithms and how they process our data is not available to us. It remains proprietary. It should be the other way around. The second trade-off that we have accepted is that the access to data is narrow, exactly what you described, the complication of setting up a clean room design so that the few people who have access to the full data, they can do everything with it, so they need to be trusted, they need to be vetted, they need to be embedded in a process, legal, compliance, technical, because once you have access, you can do pretty much what you want with it. There's some ways to restrict it, but you know, even at Bundesbank, we have a clean room design that checks you for cell phones before you enter. It's not a perfect system. Again, access to data is narrow. Once you have access, you can do what you want with it. And again, this trade-off should be exactly the other way around. Once you create data, what other people can do with it should be limited by your decision. And if that is the case, you can open it up to a much broader range of people, to more researchers, more things being done on your data. And I think the problem boils down to how we control data. So I'm going to talk in the first part a little bit about our analysis, and a lot of that goes back to a book with Katharina Pistor that is coming out next year, or maybe later this year, on the origins of why data control is the way it is today. And then the second part of the talk is joint work with a PhD student of mine, where I want to show you a platform or a system that actually does it in a different way. So what's the problem that we're trying to address? Today, if you want to share data, you are suffering from privacy is like virtue. You can only lose it once. And once you have lost it, you cannot regain it. So if you wanted to combine private and sensitive data, to entities, to companies, for example, one needs to share it with the other, or both need to share it with a trusted third party. There is not really an alternative today. I think the most common way is this clean room design where you share it with a trusted third party who then has to go through great length to de-identify the data, make sure that re-identification attacks are not possible. It's a whole complex undertaking. I think there can be a better way where both entities can combine their data in a way that they don't have to trust any third entity, or not in the way that you might think of it. Why does it matter? Well, you know, you've all come and seen sort of empirical work that your question earlier is exactly the limitations that I have encountered several times. At Bundesbank, we had the situation that the same institution had two different departments collecting two different types of data. One was collecting statistics data, the other one banking supervision data. We were not allowed to match this data internally within the organization to run, you know, basic econometric analyses over the joint data set. Why? Because different legal standards and different legal origins for why the data is collected existed. Bundesbank's solution was to take 3 years, several legal assessments, and setting up a new division with a new legal framework to combine the data. But not everybody has this ability. You can't just set up a new division, make your own law, just so you can combine the data that you would want to combine. The consequences is that data remains siloed, it remains inaccessible to research, we struggle with reproducibility, and in the end, data remains underused. The precursor to the analysis of what's wrong with the way we process data is that we need to understand that data is relational, which means if I contribute data about my credit history, for example, to a data set of credit histories, my additional data can allow data analysts to predict something about people that are like me. So people with the same, you know, age, experience, gender, education, income. So all these observables that you can collect allow you to predict something about the credit default or the credit worthiness of another individual that looks like me simply by virtue of me combining my data to a larger data pool. Acemoglu has a paper on this called Too Much Data. There are externalities involved in the creation of data, and that is only the most direct form of relational data. Salome Viljoen, a lawyer at Michigan, she has a very nice paper on this. The creation of social media data, where I click on a like because I liked Brian's keynote this morning, that creates additional information that I create about your presentation, about you, that you cannot directly control. Again, there's a relational nature in the way that data is controlled. However, the way it's currently handled doesn't reflect this, and that boils down to what we call the battles of the digital age. There's a few key moments in these battles, and I just want to sort of give you the overview so you understand why the change that we are currently seeing with technology actually matters. When you go a little bit back to how technology evolved, and you look at sort of the different dimensions of an information infrastructure, storage, computation, communication, one of the key moments was the development of Unix, because before that, we didn't really have users. We didn't have the ability to enclose data as users. All we had were mainframe computers and the wizards that operated them and controlled the physical access to the data, which happened through punch cards and physical measures. With the emergence of Unix as an operating system and Multics before it, that changed. We started to have users had accounts, and these accounts had rights: read, write, and execute. In doing so, and in implementing the copy function, which for me is the main culprit of all the things that are wrong with social media, the way it was implemented was as a read from to, but without a memory. We lose track where data comes from, how exactly it was processed when we copy on Unix, on Windows, on pretty much any operating system that we have today. That itself sows the seed of enclosure that we are still suffering from. There was a golden age of privacy, and this was the late 90s, the early 2000s, when data was enclosed, but this enclosure happened locally on your personal computers at home, not in the cloud as we have it today. So during that time, we had the golden age of data control that came to an end with the emergence of the cloud and the enclosure of all of our personal data by central data controllers. Jaron Lanier calls them the siren servers, and there's a lot of sort of negative consequences of allowing this much data to be controlled by a few central entities. So we live in what you could call the despotic data dominion, with a reference to Blackstone's despotic absolute dominion, meaning that whoever has the physical control over the infrastructure, the data centers that house our data, they control how it is processed, not the creators of data. This despotic control is an irreconcilable conflict with the relational nature of data. And I think this is at the heart of the problems that we are seeing today. However, I would not be speaking here if I don't think there's some things we can do about it. So let's dive a little deeper. Why is this idea of provenance of data so important to recognize the relational nature of data? Well, first, it's not that the system we have today is entirely without alternative. When Unix was developed, people had an actual discussion around how should we implement the copy function. Do we need to keep track of where a file comes from, who handled it before, and how? If we had done it this way, lots of the problems that we are currently dealing with through compliance and legal measures that by their nature are difficult to enforce and expensive would not have happened. Back in the days, there were alternatives. The same applies to the internet. The way Tim Berners-Lee and in particular André van Dam and others at Brown University, who, by the way, is to blame for a lot of the things that are wrong with the internet today. So if ever you wonder who's to blame, go to Brown. They take a big share in this blame, because they pushed for hypertext to be implemented as one-directional linking, so that when you click on a link, you don't know where you came from. The consequence is that we need cookies, advertising IDs, all these ways, sort of these artificial ways to track where a user was before, that infringe the user's control over their personal information. That all goes back to the idea of having hypertext as one-directional linking. It wasn't without alternative. Ted Nelson proposed an alternative system that he called Xanadu. Unfortunately, he never had the technological means to actually build it. Wired called it once the longest running vaporware story in the history of the computer industry. So what we have taken on in a way is to, actually finish this project. I'll see at the end how the demo goes, whether we were successful in this. But the conclusion is that Ted Nelson was right. Information needs provenance. Hypertext should have been bidirectional. If we had that, a lot of our issues today could be handled in a very different way. And it's not that we don't have systems where information has provenance. Academic research has the social norm that we cite who influenced our thinking. It's a weak enforcement mechanism, but it is one that exists nonetheless. Open source software has a technical requirement that all the packages you are using must be referenced. So you can reuse existing code. So provenance is enforced as a technical necessity. Likewise, and this is, I think, the technological change that we are seeing, why somebody from a blockchain center would even talk about a topic like this, is that with blockchain we have a method, not the only one, but a method that allows you to delegate control over the provenance of data from a single entity that could rewrite the logbook of who had access to the data to a broader set of nodes, to a broader set of operators that only if they all collude would be able to rewrite this ledger. So if we have a decentralized system, which is not easy to achieve, there's lots of dispute about this, but let's say we have a decentralized system with a few hundred node operators, and many blockchains have that, they would not be able to just rewrite this ledger. So the challenge remains, how do we do this with private data? For public data, it's easy. We have digital collectibles, these non-fungible tokens, the Bored Apes of this world, that were traded publicly, like you would trade your baseball cards or soccer, Panini, pictures. But that doesn't solve the issue of what do you do with private data, and that's what we really want. We want to be able to do this with private data. This is where the idea of digital rights tokens come in. So the system that we've come up with and that I want to present to you is a system to manage such digital rights tokens. The idea is that users can create private data that they have enclosed. Think about your geolocation that you could collect on your phone, or personal preferences, or your browser history, whatever you would like to make accessible in some way, but not disclosed to the public. Any form of private information. They can come together and put this information in a data pool. This pool sits within an enclave, trusted execution environment, that uses its own key to encrypt the data. We can attest that the operator of the infrastructure, us, does not have access to the data itself. There's issues with trust execution environments. They're not perfect. We can talk about them later. But you can create a pool. Alice can create a data pool, one with a credit history, one with a medical history. Bob and Barbara can decide they jointly create a pool of like-minded data, of similar data that they want to combine and make accessible to third parties. And they encode, using a digital rights token, how exactly that third party can use the data. Meaning they can put in this token exactly what code can be run on the data. Now, if this enclave that stores the data, that uses its own key, communicates encrypted with an enclave that has its own key, that can execute the code over the data, and we can prove that the operators don't have access to those keys, we have solved the issue because we cannot infringe on the digital rights of the data creators because they are recorded on a blockchain in the form of a smart contract. So you can create these pools, you decide which code exactly can be run on your data. You could decide how often, 7 times, 12 times, 1 times, by whom if you really wanted to. Or you can say, well, anybody can, as long as they acquire the right to do so, anybody can run this particular code over my data because it's code that doesn't infringe my privacy beyond what I'm willing to give up. And then if you are a data analyst, you can acquire one of these tokens, you can send it to the enclave, and that enclave pulls the code that is referenced in the token, executes it over the data, takes the result, encrypts it, and sends it back to the data analyst. This way, you can prove to the data creators that their data is only used exactly as they prescribed. So let's see if the live demo works. So this is sort of several years of work that we've been doing, and we've never really quite were able to actually implement it until my brilliant PhD student, Bingle Kruger, actually learned about the magic of coding with Gen AI, and he managed to do it in a year, basically. So this is the new world we live in. So we have this platform that it is live, actually, so let's see how this goes. There's a backup video, just in case, but I try to do it live. So you can log into this platform that looks a lot like normal cloud platforms today. First thing you need to do, because we do tokens that are issued on a blockchain to manage digital rights, the easiest thing to sort of transfer them is to actually have blockchain-based tokens to transfer these rights. So you need to log into your wallet. In Brave, it's already implemented. You link your wallet, and then you can start sort of playing around with the data. So the first thing you can see is this is sort of all the data pools that have been created. There's already one with credit data that I tried last night. So let's say I wanted to set up a new data pool. What I would do is I would go to pools. I would select first a schema file that describes how the data looks like exactly. So this is the credit profile schema, and it just looks like this. So it's basically just customer ID, all the covariates you might want, including personally identifying information if you want to, because we prove that we cannot access it. And then we upload a credit profile data. So this is, think about a bank or somebody that has a bunch of customers with a credit history. They want to combine this with other banks' credit history data or with non-traditional credit provider data. So you can upload this, this credit profile data, all right? And you can start creating a pool. So then you can decide which kind of rights do I want to assign. So you can say, well, I would like others to be able to add their data to mine. And we have implemented two specific rights. One is to compute the median, because the median is really hard. The mean is very easy. For those of you who are interested in privacy tech, there's a big difference between the two. So we implemented the median, let's say in Python, and you can start creating this pool. You need a description, credit data BITSS. And you can decide how many ownership tokens to implement, governance mechanisms do you want to have, how many tokens do you want to supply for the compute median, how many tokens do you want to supply to append new data, and you start on setting the pool name and create this pool. So now you have to approve that you actually want to do this. This will happen through the wallet. So what happens in the background is the enclave is being spun up by the system automatically. I have to, this is a bit annoying, but it's like 7 times I have to approve different transactions to prove that I really want to create, this enclave with this specific right. So it's the maximum transparency that you can have to show the user, yes, this is exactly what's happening in the background. I'm going to do this a few times. It's starting to set up the minting of ownership tokens. It's starting to set up the append data digital rights token. It's starting to set up the median digital rights tokens. All of this is happening. And then the one step that's going to take a minute or two is now it's waiting for the enclave to finish spinning up. There's some stuff happening in the background so that the enclave is actually spun up in the cloud. And in the meantime, you can have a look at existing enclaves. So here we've created a couple where you can see, well, okay, one, this is actually live, so you can see this exists really on, an actual blockchain. This is Solana, but any other one is just as good, any but Bitcoin for that matter. It's live. You can sort of verify this enclave, and this is a key thing to prove to the users how exactly we process the data. What we do here is we say you can get a verification which specific code we are currently running over your data. This code allows you to send Python code to us, but we cannot, there's no backdoor in it. We cannot copy your data. We cannot take it away, infringe your rights in any way. So you can attest to that, and there's a sort of a specific test that runs, and you can then use the result of this test to check for yourself that, yes, only what I've approved of is actually running and accessing my data. So this attestation is gonna run for a little bit. It's gonna verify eventually that, oh, it can't because it's doing the other thing in the background. So, but eventually it's going to attest, yes, indeed, there is, the enclave running in the background. It does only what we want it to do. And as I said, it's going to take a few minutes to sort of wrap this up, this enclave. What we can do then is we can go and we can acquire these rights tokens. So if I'm a new data creator, another bank, for example, and I want to add data, I will need the right to actually append it. If I am a data analyst who wants to compute some code, and actually this goes for any and all code, so there's no restriction. We've done this with the credit register for South Africa, and we've run machine learning code over this credit register within one of those enclaves. So it goes for realistically large data sets with realistically large code. And that makes it possible to use it in a way that we couldn't do 2 years ago or 3 years ago, where these enclaves were very limiting. All right, so it's going to take a little bit to do this. Then you'll see how I can, maybe I do this. I have to wait a little bit. Going to take just a bit to set this up. Eventually it will finish, and you can create a marketplace for those rights. They can be sold and resold. They can be assigned. I can say, well, we're going to get a law firm that verifies that what we are claiming here is actually true, so that if you want to deal with the mining company that is stingy, concerned about their data, you can say to them, here's a legal assessment that what you would give me is GDPR compliant, is HIPAA compliant, whatever you can think of, because this will take away the liability from them. So by simply doing that, you can just show them, okay, you are not liable. This system really works only by executing code that you approve of. We have no other means of accessing this, and it's a very nice way around these existing limitations. So now we have created this new data pool. Let's see if we can do the verification, the attestation of the enclave. Oh, maybe it runs too long as well. Yeah, so now we can see, okay, it has been verified. You get this sort of output that you could, in principle, check that, yes, indeed, that's exactly what these guys have been promising me, what would be running over the data. And you can then go and you can say, well, for this new BITSS data pool, I want to acquire a couple of rights, so I want to buy one of those rights to append data, and I would like to acquire 2 of those rights to compute the median. Okay, so we're going to do this twice. And you can then go and select your pool to actually do all these things. Whatever rights you have acquired, whatever rights the creators of those data pools have, been ceding to you, have been granting you, you can actually, redeem them. So here, the first one is you can append data to this pool. So you have to go to the existing pools list. Here we have the new data pool. You can say, I want to join the pool. So I choose a new file. So this is a new data point that I am appending to the pool now. I can say, well, let's validate the data. Yeah, it matches the schema. I want to select to this pool. I want to join it. Now it's appending this data. Again, it's end-to-end encrypted from my computer all the way to the encryption within the trusted enclave without us seeing anything other than that there's a communication happening. So it's appending this. It's creating a log on the blockchain that this is what happened with the data. We had one pilot with a medical company that was very concerned about manipulation of medical trial data because they can't verify how exactly it was handled. With our system, you can prove how exactly the data was handled from its inception all the way to its ultimate use. That's the power of provenance of data. So we've appended the data to the pool, and now we could redeem the median DRT if we wanted to. So here we have the, it's home. So here we have all the different digital rights tokens that we have acquired, and here we can redeem the, computing the median. It links to a GitHub URL of what code we're actually pulling. So it's just, compute the median. The code is public, the data is private, exactly as we want it. We redeem the DRT. Again, there's a log entry created on the blockchain. The computation is running, and you get the result that the new credit score is on the median of the credit score is this, and the credit utilization is that. You don't have to break the link with the original data creators anymore, because their data is still encrypted, inaccessible to the operators of the infrastructure, which means you can keep it encrypted. You can prove you don't have access, and if in the future you want them to actually approve access to it, you can still do this. So what we've done here is we've sort of used a different model of how we access data, and it's not just, you know, pie in the sky kind of idea, but this is something that is ready to use, and that, you know, within the limitations that trusted execution environments provide, you can actually use to handle and create data control. So this combination of secure enclaves plus blockchain plus oracles to combine it. I haven't spoken about this, but you need to combine blockchain and the enclaves, and enclaves are a bit tricky because they don't have states. But you can do this using oracles. This is, for the first time in history, a way to fight this digital despotism that we've been suffering from since the creation of the copy function. So it took us something like 60 years to fix what they did with the copy function, but I think this is a practical way of doing this. So with that, I'm very happy for any questions. I think we have like 2 or 3 minutes. Thank you.
Any questions? We're all just waiting for this to happen. We want it to be real. Aidana, could you get the back?
Hi, my name is Gauthami Penakalapati. This is really fascinating. I think it opens up opportunities for low-income citizens in countries to really protect their data and even potentially get paid for it. I know this is just the beginning, and I find it a little complicated. What do you envision it to making it even more accessible for this to be a digital right per se?
Okay, thanks. Yeah. So we have worked a lot on creating versions of this for people who don't have smartphones and don't have access to a computer. The only thing they need is to know somebody who has a smartphone, and they can use a system like this to manage their digital rights through their normal feature phone. Half the world's population doesn't have a smartphone, so how to include them actually matters. So the moment you can prove to users how you process their data and that you cannot see it and you can prove it, everything changes. The way we handle data changes completely. We flip these two trade-offs that I mentioned in the beginning. We completely flip them on their head. My personal vision would be to have digital rights that you create as a basic income, basically, universal basic income that you assign to everybody. They can use them or trade them if they don't need them, because this is one of the few ways that I can think of to transfer wealth from the north to the south. And it's an easy enough way to do it. So we set this up. It was used for central bank digital currencies in Bhutan and Palau, where we had issues with access to digital payments exactly because of the problem you mentioned.
So I don't know if you're actually a subject expert on this, but to what extent does this really help you get around things like HIPAA and the European health laws? Because I can imagine, like, you know, I want to get health data from a number of people that have reasonable concerns about sharing it, and, you know, my inability to pay enough lawyers to like deal with that, right? But can I actually get them to legally put data here, and I can run code on it and they can send it back? And to what extent can you stack various people's data that you have multiple tokens for, so you can compile a larger data set?
All right, very good. So sharing is bad in our world, because sharing means you give up any control over it. We do not facilitate sharing. We facilitate joint data control. It's a subtle difference, but an important one. You can set up a pool of data. We've spoken with the medical trial guys at UCT and so with this company. You can combine your medical data with other people's medical data and say, we will only allow this piece of code to be executed by that entity one time. That is very different from the restrictions that GDPR and HIPAA and others place on you. And they place these restrictions because they struggle with proving how the data was used once you give up control. Once you've lost your virtue, it is very hard to regain it. And that is exactly what we are getting around. And this is why I'm saying that I think the one thing that we probably should do is to get a law firm to actually write a legal opinion saying this actually gets you around this issue. But having worked with Katharina, my co-author, who is a lawyer, I'm very confident that this is indeed the case, because it's this residual use that we are eliminating as a possibility that changes how you comply with the law. Yeah, exactly, but we remove the ability to do anything. Yes, exactly. So the law is problematic and is concerned because you cannot restrict how somebody else would use it once they have your data. That's the real problem with it, and we are removing this piece. Good. Otherwise, let me just say, if you have data that you always want to have access to and you want help convincing a company or other entities to try this, talk to me over the next coffee. I think there's a nice and easy and a new way to do this now. Cool, thank you.